Stacey. I'm the IT systems architect at the City and County of Denver. And I want to talk to you a little bit about the Redfish API and how you can use it to automate your host building from the bare metal up. So everything can be infrastructure as code all the time. Just a little bit about myself. I've been part of the VMware community for about 10 years now with vMug. I've been a V expert for 7. I'm in my second year being in the Tanzu Vanguard, and with my first year of being a Denver vMug leader. So been around the community for quite a while. I'm happy to share something I find interesting with you, and hopefully it might help you in your day-to-day work. Have a few slides I want to go over before we jump into demo, where all the cool stuff is. We're just going to talk about what the Redfish API is and why you'd want to use it, and then give you some tips about getting started and taking a general look at the structure, just so as we're going through the demo, it makes a little bit more sense. Redfish is an API solely designed to automate the software-defined data center. And this isn't any one vendor's software-defined data center. They just mean your data center. Primarily started as server automation, like we're going to talk about today, but has expanded far past that into many other aspects. It was released in 2015 by the DMTF, which no longer officially stands for anything. That's just their name now, and I get the letters backwards all the time. And their entire goal was to modernize the IPMI or BMC management of servers and to kind of push standardization across the industry. So as you might be changing hardware vendors or even models with how vendors like to do things, you wouldn't have to rewrite all of your KBs and processes to fit a new standard. As of July, they're up to version 2024.2. They've expanded to do stuff like storage fabric here. They'll even started hooking into more of the facilities type stuff with like power distribution units. So you one day might be able to program an entire rack up with Redfish API as long as you can get to the management interface. Its primary plus is it's vendor agnostic. There is no one vendor that owns this solution. It can work across many, many vendors. Dell supports it, Cisco supports it, HPE supports it, Supermicro supports it. The list goes on and on and on. It allows you to adopt that infrastructure as code mentality all the way down to that hardware level. So you may already be using things like auto deploy or other automation tools for the ESXi install automation and automating well above that layer. But the hardware layer kind of gets looked over, and no one likes sitting there at a console putting in BIOS settings every time you get a new host. With that, it helps increase the efficiency and productivity of expanding your environment, and it can even start to help you monitor and maintain configuration drift across those hosts over time. How to get started. The first step is to identify whether or not your gear supports Redfish API. It is a very widely supported, as I mentioned, but depending on the age of your gear, you may or may not have it available to you in that particular model. The vendors did not all adopt it on the same day, so your host from a year ago probably has it. Your host from 5 years ago, it's a little more iffy on whether or not it's going to be there. You may also need to go into the host and enable that. Some of the vendors are keeping it disabled by default as more of the customer opts into using it rather than it being on by default and the customer not knowing it's there and having another API entry point that they may not want. And then the biggest part always is coming up with a plan. If you sit down to learn the Redfish API without a plan of what you want to accomplish with it and how you want to start that process, it gets real messy real fast because there's a lot to the Redfish API. So it's just good to sit down, and even getting at this point, figuring out which host you want to be your golden image host to kind of copy the configurations from. That's probably a good place to do it here. I'm by no means a developer. I came up through infrastructure, hardware, virtualization, all that stuff. When I see a new API, it looks like Latin to me at first. And that happened with Redfish. And I'll kind of go into a little bit here some of the tools that helped me process it in my way. And that kind of the point that I'm sure everyone's heard, but it's good to hear repeated every once in a while. Everyone learns differently. So if you find a tutorial online, or if what I'm showing you sounds interesting but doesn't make any sense, there are multitudes of other sources of how to learn this, and just accept that you want full videos to see it, or you want full blog posts, or just want to tear through a GitHub repo. There's multiple avenues up there, so just do what helps you learn the best to get through it. And part of that, or kind of alongside of that, start small and build up. You made your plan of what you want to accomplish, but don't tell yourself you're going to write that entire plan all in one go. Start with, how do I get information about a host so that I can pull it apart and change what I need? How do I change a BIOS setting? How do I mount ISO to the virtual drive? If you start with those small blocks and kind of snap them together by Legos, you get full automation much more quickly, at least in my case, than if trying to accomplish it or attack it all at once. I mentioned there are some different tools to help learn this process, because I don't like reading curl commands and it makes my eyes glaze over. So you can use API clients like Postman, Bruno, and in VS Code or browser plugins if you want to do that raw API at the keyboard type of stuff. If you have a scripting language, CLI, that you are very familiar with, PowerShell, Python, anything like that, there are Redfish plugins and modules for the majority of those that help bring that API into whatever that language's format is, which can be super helpful. Or you can go with bigger automation tools. These get complicated really fast. Don't be like me. I decided to learn Redfish and Ansible in the same time, and it made this way more complicated than it needed to be. If you're all familiar with one of those, there are plugins to do it. And if you wanted the challenge of doing both at once, great, but it's a lot. Looking at the structure here, on any interface, it should all be the same base. There are places for vendors to put their custom OEM stuff in there, but that or IP2/redfish/v1, you should get a JSON prompt back going, hey, yes, there's something here if Redfish is running on that endpoint. The middle section there, the systems, managers, chassis, and task service, those are kind of the module, some of the modules of Redfish. There are a bunch more that just didn't fit on the slide. Systems is where all the stuff you would normally think of server information of, the CPU, the RAM, power supply, stuff like that. Managers is where all the settings for the IPMI interface, BMC interface are going to be. And then chassis is mostly there for bladed systems or more multi-node converged systems. Rack mount servers, a lot of this data is just going to be replicated from the systems level. But if you have, say, like the UCS blade, you could connect into that blade and then you'd have information for the whole chassis, but then you can hit each individual system. And you would do that using the ID monikers. So when you first start doing this, you do have to kind of interrogate that system a little bit to figure out what the vendor did for their system IDs and kind of some of the where they put a few of the things that are allowed to move outside of the standard. But it's usually a few quick git commands to get that, and then it's the same across models a lot of the time. Task service is where all the information for jobs that you submitted to one of the other namespaces are going to show up. In Dell terms, this is a lot of the lifecycle controller information. So we're going to hop into the demo. I'm going to test the demo gods, which, you know, that goes well some days and not others. What I'm running in the background is a tool from DMTF called the Redfish Mockup Server. And what it lets you do is create a fake iDRAC to run locally so you can test commands back and forth. And I've downloaded a Dell iDRAC profile that Dell has out on their GitHub. So we're going to be talking to a fake Dell server for most of this. But again, it's vendor agnostic. That was just what worked. I don't know where the mouse went. All right, so we're going to start in just Bruno, looking at it through the raw API so we can see more of the structure before we take a look at Ansible versions of this that kind of obfuscate it but make it a little bit more human readable. The first example here, if we look up at the top, we're going to go to the endpoint address of my fake IPMI. In this case, it's just localhost, I think port 8000. We're going to go to that Redfish v1, and we're going to take a look at the system section, which again is all that server information. And the server ID for Dells is usually just system.embedded and then a number. And then I want to pull the BIOS settings, because that's going to be one of those tedious things no one wants to do by hand over and over again. When I send that, what I get back is just JSON. All of Redfish is based around JSON as input and output, so it's all very standardized. You don't have to worry about if you need to pass YAML here, JSON there, HCL somewhere else if someone got real weird with it. If we scroll down, we'll go to attributes, and we'll start to see all those BIOS settings just listed out with their values. And that is what the server would have configured at this very point in time. So a place I found nice to start is to do this, copy this JSON out to VS Code and manipulate this list, because it's what you're going to feed back to Redfish in order to set all the items. And I personally, even if a lot of these are the default, I personally like to pass all of them back in case a vendor decides to change their mind on what the default is. You're not left guessing on why a new host booted weird after your infrastructure code was applied. So just, I like to submit everything, and I don't have to worry about it in that case. If we want to change a setting here, I want to make sure we're in UEFI boot mode and that secure boot is enabled. It comes disabled by default. So I'm just going to put a patch command, because I don't want it, in this case, I don't want to submit all the settings. So I'm just sending a patch command so I can change the value of these two settings. You can do a put and it would work, just patch, because I was feeling like it, I guess. Now, because I'm running a demo iDRAC, there are a few weird things that don't always make this a great example. A lot of the time on a real endpoint, you will get a response back of saying, hey, I got it and we're good. This one doesn't. I just get 204 back, no content. But what I can do is we'll just go back and we're going to rerun that BIOS command here. And I'm going to try to get this the first time without having to hunt for it. I'm going to try to find secure boot here. So secure boot is now enabled. So that's just an example of one setting that you've applied in there. But again, through a full automation, you would likely be setting the majority of these, if not all of them. Another example is if you wanted to have your automation make sure your firmware is all in the correct version. We're going to take a look at the firmware inventory, which lives in the update service, which, like the others I had up on the screen, is another one of those modules of Redfish, primarily taking care of firmware updates and keeping track of all those versions. And I'm just going to look for the firmware information for a fake RAID card that the system has. And we pull it back, and you can see the name of it, the version information. You start to see little tidbits of Dell OEM information in here. Again, the vendors are allowed to add a little bit of their own flavor in here, so you can't necessarily take the exact code and drop it between like a Dell and an HP. You'll have to massage it a little bit, but it shouldn't be a terrible amount. And once you've done it once, the structure should be the same, so it's just kind of a find and replace in most cases. Next, we're going to take a look at working with the virtual CD drive. So we're in the manager section, which in this case is an iDRAC. We're looking at virtual media and then the virtual CD-ROM drive. there's nothing attached, so it's not very interesting. But this is the space that you would interact to attach your ESXi ISO for the install, or whatever operating system you want to throw on there. You would interact with it, and you would reply back with just something that looks a little bit like this. Again, we're still in that same spot, but we're using a actions area of the iDRAC, and I'm inserting virtual media into it, and I have a fake web server I'm hosting a fake ISO off of. This won't do anything because, again, the fake iDRAC doesn't like fake ISO files, so we're just kind of faking each other out a little bit. So that's how those kind of basic concepts work. As a full automation, you have a lot more, and that's where getting into some of the other automation tools to help you structure that and make it more operationalized will come in handy. So we're going to look at doing something similar with Ansible. Now in 25 minutes, I don't have the ability to go in and teach Ansible on top of going over the basics of Redfish. So you're just going to have to believe me on a few parts if you're not overly familiar with it. But Ansible has modules out in Ansible Galaxy. It's their collection for all of these modules of different things. Most of what I'm going to use, if not all of it, is just going to use the general Redfish one. There are vendor-specific ones that change the format a little bit. You get a little bit more data back sometimes because it knows how to query those OEM spaces within Redfish. But majority, if not everything, can be done with the general one. Again, kind of moving between vendors if you don't have a unified vendor for all your hardware a little bit easier. So what I'm looking at is the Redfish info task, and a lot like that API structure we were looking at in Bruno a few seconds ago, I'm going to call the systems section, and I'm going to say I want to get the BIOS attributes. I give it the connection information, never leave the iDRAC password as Calvin, and if we run it, this is what an Ansible play looks like if you have not worked with it before. It is running a lot of this in the background. You don't get to see a whole lot because I have all the verbosity turned off because it turns into a mess really quickly. But what it returned is that exact same list that we looked at through the API call directly. So this gets you all the same information, but it's a little bit more human readable than trying to remember all the API strings and all that stuff. And like, I don't have to give it the system ID here because it just goes and asks the host what the system ID is, and then it uses that in its call underneath. So it takes care of a lot of that sort of stuff for you. Similarly, we've got boot mode, right? This is what that would look like. Again, I'm just passing those two attributes into there. A full one may look much different. You could have everything listed here, or there are ways to pass template files of very large values in Ansible. That's out of the scope for today. That one gets a little complicated quickly. And if we ran that, it would look a lot like the other one we looked at here just a second ago. The last sample here I have is looking at the virtual media. Sorry, my brain stopped there for a second. Again, we're looking at the manager space, so asking the iDRAC what virtual media information it has. If I run this one, it is just going to come back and give me a big old goose egg because I can't mount fake ISOs to a fake iDRAC. But again, it's going to go through and do all that in the background and then return back that same blurb from that we saw through the direct API call, and it's still in JSON format. With Ansible, one of the tricky things that I ran into is there is JSON in there, but it's also within an Ansible data object, so you have to learn how to parse down to the JSON, and then you can interact with the JSON like you normally would. I know not all the modules. The community Redfish ones are pretty good about returning the same structure. I've worked with a few of the other vendor-specific ones, and not all of the modules always return the same structure. Just going to hop over to the last slide here. To operation and all, you'd probably eventually put this into a pipeline tool, Jenkins, GitLab, whatever like that. It would allow you to take a few inputs, say the IP address of your BMC and whatever host name you need to give it. It could then start going down the process using Ansible playbooks and containers. It could get all the information, take that information, fill in other variables, and then push that configuration payload to the server, verify that everything took correctly, and then you could throw in some fancy stuff at the end, like getting it into your CMDB and monitoring and all that stuff, so that when you get a piece of hardware, you just rack it, make sure that management interface is connected, you should be set to go. That's all I have. Please take a moment to fill out the survey. That information goes back to Frankie and team for the community stages, lets you know how I did. Lets me know how you think I did, so that if you want to see more of this, I can plan a talk for next year, or if you don't want to ever see me again, I will stay away from the stage. So thank everyone for coming, and have a great day. Yeah, I do have the session again tomorrow at noon.